Welcome to my lesson 2 video. In this lesson you'll be learning about basic math needed to actually understand physics. Now, let's get into it. Let's do some warm-up problems first based on the past video. So in the last video we learned about vectors and how to add and subtract them. Okay, let's see. The first problem. Add the following vectors and 2 and 5. So to add vectors, let's follow the steps. 1. You have to connect the head of the first vector to the tail of the first vector. So for doing that, just write an expression or an equation. So we can do 5 plus 2 or 2 plus 5, doesn't really matter. So let's just do 5 plus 2. So after you wrote that, then connect the head to the tail. So right here, that's 5, and that's 2. So then connect the tail to the head to get what 5 plus 2 is, which is 7. So the answer is 7, pointing down that way. Okay, well, that's number 1. Well, if that seemed easy to you, then you're all good. You understand how to add vectors. Now let's get to subtracting. So when you're subtracting, you don't want the small one to subtract. You don't want the big one to subtract from the small one, but you want the small one to subtract from the big number. So in this case, you need 11 minus 5. So since you have your expression, now let's draw our vectors. Okay, there you go. So 5, wait, I don't have enough space. So negative 5 is the opposite direction of 5. So which means it's probably this way. So you see you get a right triangle. So to find what the you see that you get a right triangle here. So to find what the resultant is, that's what this is called, the resultant or the displacement vector is, you have to use the Pythagorean theorem. So 11 and 5. So 11 squared, square root of 11 squared plus 5 squared is 121 plus 25. So then that's 146. So square root of 146 is, let's see, it is 12, almost 12, but 12. Let's just say it's 12. So the answer is 12. Okay, now let's get into the actual lesson. Okay, so before I start out this lesson, let's see what you learned. So number 1, you learn about units and dimensions, and mostly SI units, because they're really important, since SI units are like what describe like lengths and dimensions, which you'll learn later. To dimensional analysis. Dimensional analysis depends on units and dimensions, so that's really important too. Number 3, significant figures. This is mildly important, even though most of the questions ask for you to write this, but this is easy, but it's really important too. Okay, scientific notation, the big one. This one, most of the questions, if not all of the questions, use this. Maybe some don't, if they don't have like really large numbers, but at the start, when you're a beginner and answering questions, you wouldn't really notice people writing in scientific notation, but when you get to big numbers like 5.3 million, that's literally like they write it in a specific way, which is called scientific notation. Well, if you read the question and don't know what the way that it's written in is, then it's really hard for you to do it. So this is really big. This scientific notation is really big. Okay, well, let's get into this lesson now. Okay, so before getting into units and dimensions, let's see what they mean exactly. So, units. Units are measurements that are in a specific dimension, like centimeters and kilograms. Well, so this means that unit depends on a dimension. So let's see what a dimension is. Dimension is a measurable extent of some kind, length, time, weight, etc. So if units mean something that measurements that are in a specific dimension, then you can say that centimeters is a measurement in the length dimension since it measures the length, and the kilograms is in the weight dimension, which measures the weight. Okay, so let's get into SI units. Okay, so SI units. So let's start off with the definition. Well, it just means the international system of units, where these units are internationally used all over the world, so that there is no confusion. Like in the U.S., people use pounds and then ounces, which confuses the people who don't live in U.S. So they created an international system of units to make it clear and to make so that everybody has the same units, which make it more accurate for everybody. Okay, so the SI units are assigned to specific dimensions, and they don't change wherever you are in the world. It depends on if they use SI units. So here are some examples of SI units, like the dimensions for length. Every dimension has an SI unit, but the three that you have to know is the length, time, and mass. So for length, the SI unit is meters, and for time, it's seconds, and for mass, it's kilograms. So for the velocity or the speed, it's meters per second, or depends on what the length and time are. If in the question they mention another measurement, that means it's not based on the SI unit, it's a literal measurement. And for time, most likely in the questions you answer, you're gonna use seconds, but if they say minutes, you can convert it to seconds, since seconds is the most convenient way to answer a question. And weight, you don't really use weight in the introduction to physics or in the motion part of physics, but it is also important since kilograms is used in free fall motion, which you'll learn later. And yeah, that's SI units. Okay, now let's get into dimensional analysis with these units. Okay, now let's get on with dimensional analysis. So let's start off with the definition. Dimensional analysis is when you do algebra with units. That's my way of saying it, if you understand what it is. So I mean like playing around with the units. So if you have centimeters over seconds times a second. So imagine there's 1 in front of all of these, and what's you can remove, so 1 centimeter divided by 1 second times 1 second. So both seconds time the cancel out, which only remains with 1 centimeter. So that's dimensional analysis. So when you hear about it, you don't think it's easy, but it's actually easy when you understand it. So here's a rule that's really important. So when you do dimensional analysis with units, you cannot have the result having different units on both sides of an equation. So for me, I had centimeters, the result, but that was only the expression. If I had like centimeters is equal to seconds, like in the example, it's not equal. It's not equal. This is wrong. This is wrong. And if you have centimeters equal centimeters, then that's right, because centimeters is equal to centimeters. So now you may have a question, why cannot centimeter be equal to a second? So here, let's think about this logically. If you have 1 in front of a centimeter and 1 in front of a second, can 1 centimeter be same as a second? No, right? Since centimeter is length and then 1 second is time. So from this you know that both sides of the equation have to be having same dimensions. So this has length to seconds. That's not good. If you have length to length or time to time or weight to weight or speed to speed, then that's good. That's correct with dimensional analysis. Okay, so let's look at an example. So you probably have a question how to do dimensional analysis. I may have explained it, but you still may have a question. So this is an example that can clear it. So write out an equation. Sorry for that mistake. N with only units without numbers, and then treat them like numbers and do algebra with them. So those are the steps of doing this dimensional analysis with these. So first, since you remove the units, you get centimeters over seconds times a second is equal to centimeters per second square times a second square. So this is an easy problem since it's straightforward, but some you may have to do a bit of thinking and use equations, but that's later in physics. Okay, so here you know seconds and seconds cancel out. Wait. Yeah, so seconds and seconds cancel out, and second square also cancel out. So, what do you think this is dimensional analysis based on your knowledge? I would say yes, it is, because length is equal to length, so both sides have same dimensions. Okay, well, that's all the dimensional analysis. If you do not understand anything, comment below, and then I can answer them. Okay, now let's get into significant figures. Okay, let's get on with significant figures. So, a significant figure is the number of digits in an answer that are actually measured plus one estimated digit. So, this means if you have an answer of 3.0125, and if in the question if you have the numbers 2.05 and then 3.50. Wait. 3.50. Then for significant figures, you would make this 3.0125 to 3.01. Because the digits in your question, the inputs only have 3 significant figures, which is initially the number of digits in the value. So then, if they both have three significant figures, then the answer 3.0125 will also have 3 significant figures, which when you round, you get 3.01. It's not always this case because there are some rules for multiplying, dividing, addition, and subtraction, which you'll learn after this slide. So, we can use significant figures in our answer because it helps make them more accurate. Like the number I use, 3.0125. So this is really hard to like if you try to input this into your if you try to reverse do your question and if you try to input this value, you would need a calculator because if you multiply with this number, it's really almost really hard because there's literally 1, 2, 3, 4, 5 digits. And there's a decimal point too, which makes it harder. So significant figures makes it makes it short, which makes it accurate too, because it's the number of digits in the input values or the specific value. There's specific rules too, which I talk about later after this slide too. Okay, let's see an example. Find the circumference if the radius is 2.50 meters and represent it in significant figures. Use pi as 3.14. So you might be thinking, why is it 2.50? Why isn't it not just 2.5? Well, if the question says 5.0 or adds a 0 after a number, which is not needed, it means it needs like a specific number of significant figures. So in this case, the circumference is a 2 pi r. So it's 2 pi times 2.5. So in the answer, in the work that you do, you don't need the 0 at the end, but you may have it if you want. So that is equal to 2 times pi times 2.5. That is equal to 15.7. 15.70796. So that's there's more to it, but that's the max I can go because I can't put it in the slide. But if I try to round it to near significant figures, I need 3 because this has 1, 2, and 3. This 2.50 has 3. And then when they say use pi as 3.14, that means pi has specifically 3 significant figures. Since they say 3.14, they could have said 3.1, and that's it. But they said 3.14. So that means I rounded to the nearest 3 significant figures, which is 15.7. So that's the answer for this. Okay, now let's get into the rules for the significant figures. Okay, so let's learn about some rules now. So there's 2 rules. You can consider it as 4 if you want, but I consider it as 2. So multiply / dividing rule and adding / subtracting rule. So let's do the adding and subtracting rule first since it's easier. So the rule is when you add or subtract, the number of decimal places in the answer is equal to the smallest number of decimal places in any input value. So if you say 5, so 5 plus 5.0, that's important. 5.0 plus 3.98 is equal to what in significant figure form? So if that was the question, you would just add, and then you would say, if you add it first, you get 8.98. So if you want to write it as significant figure form, it says the smallest number of decimal places. So the smallest number here is 5. This has only 2 decimal places. So then you'll want to round this 8.98 to a 9.0, since you can't round 8.9 since the 8 is greater than 5. So you have to estimate the 9 as a 10, which makes it 9.0 instead of just 8.9. So 9.0 is the answer for this. So let's look at a real example. So what is 3.567893? That's a big number. Added to 5.45 in sig fig form. So that's how they say it, since it's easier in the question to write down and stuff. So 3.567893 plus 5.45. You notice that I made the 5.45 in a different color, since it is the digit. That's the smallest amount of decimal places there is, since you can see that the other one's a really big one. So when you add them, you get 9.017893. So if you want to say that in sig fig form, then you can just round it to the nearest 3 decimal places, which is 9.02, since 7 is greater than 5, and then you estimate the 1 to be at 2. So that's 9.02. Okay, so now let's do some multiplying and dividing rule. So the rule is when you multiply or divide a set of numbers, the amount of significant figures in the answer is the same as the least accurate known input value. So that just means if you have like 5.0 times 10, you get 50. No, wait. 5.0 times 100. So you get, you get 500. Okay, so you get 500. So then if you want to make that to the nearest, no, wait. Let me give you a different example. So if you have like 2.4 times 3.6, so 67, then you get 2.4 times 3.67, you get 8.808. So when you get 8.808, you want to make it so that it follows the same amount of significant figures as the least accurate known input value. So the least accurately known input value is 2.4. That's the least compared to 3.67. So that has two input values, so two significant figures. So then the answer should be in 2. So that's 8.8. You can't estimate it to 8.9 since 0 is not greater than 5. And instead it's less than 5, so it stays at 8. So A is the answer. Okay, now let's look at a real example. So what is 21.0456 divided by 8.5 in significant figure form? So that's 21.0456 divided by 8.5. So let's just get what the answer is first, so which is 21.0456 divided by 8.5, which is 2.475952941. Okay, let's compress that a little bit, which is 2.47595. Let's just make it like that, since it's a really big answer. Not in the amount, but it's the amount of numbers. Okay, now to make that in significant figure form, you have to get the least accurate, which is the least number, which is 8.5, since 21.0456 is greater than 8.5. So then you have to have two significant figures, since 8.5 has two significant figures, which makes it as 2.5. So since 7 is greater than 5, the 4 turns into a 5. So the answer is 2.5. Well, that's it for the rules. I am thinking you learned a lot, which you did, because this video is about 15 minutes, 16 minutes long, I'm thinking. And yeah, this is the end of the video, and thanks for watching. Like, share, and subscribe, and see you in the next lesson. Bye.